Hello everyone. Last time we talked about the collection and preparation of solid and liquid samples. Before initiation of quantitative analysis, we still need to perform sample pretreatment. Today we will discuss the different pretreatment methods of sample. The sample composition is complex and the target content is low, and at different oxidation states. Pretreatment of analytical sample, namely decomposition of sample, is necessary before analytical test. After the pretreatment, the state and concentration of detected component will meet the requirements of the selected determination method, and the elimination of the interfering coexisting component will be achieved as well. So the pretreatment of sample is one of the most important steps in the analysis. Following points must be noted in the decomposition of samples. First, the sample decomposition must be complete, and no residual fine particle or powder of original sample can be found in the solution after treatment. Second, during the process of sample decomposition, the target components should not be lost by volatilization or other ways. 3. No more target components or interfering substances should be introduced. We first introduce the decomposition of inorganic samples. The two most commonly used methods are dissolution and fusion. The dissolution method, as the name suggests, is to dissolve a solid sample, so you need to choose a proper solvent. 3 principles of solvent selection should be followed. First, for water-soluble sample, water is selected as solvent. Second, for acid or base sample insoluble in water, basic or acid solvent is chosen. Third, for reductive or oxidative sample, oxidative or reductive solvent is selected. Take hydrochloric acid as an example. Except a very few metals such as silver and lead, most of the metal chloride can be dissolved in hydrochloric acid. Metals in the metal activity sequence before hydrogen and their alloys can dissolve in hydrochloric acid. Most metal oxides and carbonates can also be decomposed by hydrochloric acid. Another example is phosphoric acid, which can dissolve many minerals insoluble in other acids, such as chromite, ilmenite, columbite, and rutile. It has a good soluble effect to alloy steel with high content of copper, chromium, and tungsten. Phosphoric acid is a kind of acid with strong complex ability. Use it alone to dissolve sample, high heating temperature is unfavorable, and heating time should not be too long, generally at 5 to 600 centigrade within 5 minutes. Otherwise, there will be precipitation of slightly soluble pyrophosphate, as well as the crushing of glass due to the generation of polysilicon phosphate, adhesive on the bottom of the dish. Example, hydrofluoric acid. It is commonly mixed with sulfuric acid, nitric acid, etc., which is mainly used to decompose samples containing silicon, tungsten, niobium, and titanium. When hydrofluoric acid is used for sample decomposition, platinum vessels, PTFE beakers, and crucibles will usually be applied. Temperature of sample decomposition should be less than 250 centigrade. Fusion method. Mix the sample with the solid flux and heat the mixture at high temperature to convert the whole component of sample into compound that is soluble in water or acid based on the metathesis reaction between the sample and the solvent. Disadvantages of fusion method include that the used amount of flux is large, the crucible might be polluted by corrosion, and the melting temperature is too high. The solid fluxes used in the fusion method include acid and alkali. Let's first talk about the acid flux. Commonly used acid fluxes are potassium pyrosulfate and potassium hydrogen sulfate, which are suitable for dissolving alkali samples, neutral oxide or ore, such as corundum, rutile, etc. Rutile can react with pyrosulfate to produce soluble titanium sulfate and potassium sulfate. This reaction occurs in a porcelain crucible or a platinum dish, but it will cause a slight corrosion to platinum. To melting, the target sample is then extracted from cool reaction mixture by dilute sulfuric acid. Fusion method with alkali. Commonly used fluxes are sodium carbonate, potassium carbonate, sodium hydroxide, potassium hydroxide, and so on. Melting point of sodium carbonate. Potassium carbonate is 850 and 890 centigrade separately. They can be used for decomposing silicates and acid slag in platinum and porcelain dishes. Melting point of sodium hydroxide is 321, and of potassium hydroxide is 404 centigrade, which is proper for decomposition of silicate, bauxite, clay, etc. in iron, silver, and nickel vessels. Choose a mixture of fluxes, such as sodium carbonate and potassium carbonate at a ratio of 1:1 to break down silicate samples with high aluminum content. In addition to dissolution and fusion, there's another method, sintering, also known as semi-fusion, which is to mix the sample with the flux and carefully heat the mixture to a clinker. At this point, the temperature is lower than the melting point, at which the semi-molten mixture shrinks into a solid block instead of the whole melt, and the sample reacts with the solid flux reagent at this temperature. Compared with the fusion method, the sintering method has lower temperature and a longer heating time, but the advantage is that it is not easy to damage the crucible. Sintering method is usually carried out in porcelain crucible. The example of this method is using the mixture of calcium carbonate and ammonia chloride to decompose the silicate, and then the potassium ion and sodium ion content in silicate can be determined. Filter the sample at 750 to 800 centigrade to get the powder product, of which the potassium ion content is determined after extraction by water. The sintering reaction equation is as follows. These are three methods for decomposition of inorganic samples. Then, how about organic samples? It's necessary to decompose the organic or biological samples for determination of certain elements, such as metallic elements, sulfur, and halogen. During the process of decomposition, the elements to be measured will be recovered proportionally and converted to an oxidation state with ease to be determined, with caution to avoid the introduction of interfering substances. Decomposition of organic samples usually involves method of dry ashing or wet digestion. What is dry ashing? Sample will be put in a crucible and heated on a hot plate to make sample dry to ash state, which is later transferred into muffle furnace to go through an ignition process at a high temperature, usually at 400 to 700 centigrade, with atmospheric oxygen as oxidant to decompose the sample. The obtained inorganic residue is then extracted by a small amount of concentrated nitric acid or hot concentrated nitric acid. Advantages of dry ashing method. No or little reagent is needed, hence avoiding the introduction of impurity, and the method is simple. The disadvantage is that there is sample loss caused by volatilization or sample adhesion to the wall of the container. The second method of organic sample decomposition is wet digestion. The sample is placed in a Clayson flask with a mixture of nitric acid and sulfuric acid and cooked at a certain temperature. The nitric acid can break down most organic compounds. During the process of cooking, the nitric acid gradually evaporates, finally leaving the residual sulfuric acid. A dense white sulfur trioxide is produced and reflects in the flask until the reaction solution becomes transparent. The whole process is called digestion, during which organic matter is oxidized by acid to carbon dioxide, water, and other volatile products, leaving inorganic acids or salts. For sample decomposition, the dry icing method generally needs 2 to 4 hours, and the wet digestion method is 0.5 to 1 hour. So the advantage of wet digestion is a fast digestion speed, and the disadvantage is introduction of impurities due to the addition of reagents. Thus, the used reagents should be with high purity. In addition, we can use microwave method to pre-treat samples. The characteristic of the microwave is that when the microwave acts on matter, it can be absorbed by polar substances, such as water, acid, and alkali, leading to fast warm-up of material. Of course, ceramics and plastic are permeable to microwave, while metals and alloys reflect it. Pretreatment of sample by microwave has the following 5 advantages. Fast heating speed, strong digesting capacity. Second, low amount of reagent and low background. 3. Prevention of volatile loss and sample contamination. 4. Environmental friendly. 5. Ease of automation. Therefore, the microwave pretreatment has great potential and application prospect. These are the methods for the decomposition of inorganic samples and organic samples. Finally, we have 2 questions for you. First, before the sample analysis, why pretreatment of sample is performed? What does the sample pretreatment include? Second, how to dissolve the falling sample? Tungsten steel, pure aluminum, glass, earth, and marble. That's all for today.